Okay, so our next speaker is Gerard Phillips from Arista Networks, and he's going to be talking about scalable IP architectures. Now, a lot of the discussions we've had so far have mentioned scalability, but not really talked about how you make that happen. And I think this is really, really important to understand, how the networks can grow over time and how we make sure that the system that we put in today is going to meet our needs tomorrow and in the future. So, over to you, Joe. Gerard, sorry. Gerard.
That's fine, it's cool. Hi, my name's Gerard Phillips. I'm very loud. You hear me at the back? So I'm a systems engineer at Arista. I used to work in the R&D department of Snell, now GV. So I'm going to stand over here so the camera can get me. So I've got 22 years of experience of broadcast systems, live production, standards conversion, decoding, deinterlacing. The last maybe 4 years of that time I spent working with guys defining the specifications for the Snell IP range and doing the technical work to make sure it's going to work. So in that time, I got a really good view of what is IP. I could kind of marry that up with what the broadcast guys wanted to do with IP for live production playout. So what I'd like to try and do is just share some of that experience with you. I know in theory it's supposed to be questions at the end, but if there's anything that you really want to ask, please just go ahead and we'll just make it fit the half an hour, okay? So I'll crack on. Let me make sure I can make this thing work. No, wrong way. Magic. So, scalability. What is scalability? It's kind of adding more stuff, right? It's because you know what size you want to be at the beginning, but you don't know what size you want to be. Well, you know you want to be bigger later. So we're going to add more endpoints. We're going to need more bandwidth. We want to support different geographic sites. We may not have to do that today. We may need to do that tomorrow. There's going to be new formats and workflows. I kind of consider that scalability. And you may want to end up adding more network functions. So maybe it's a 2110 network today. Maybe you want to do something more with it tomorrow. So, maybe it's endpoints. Maybe you move to 4K. Maybe you move to 8K. Maybe VR, esports. I don't know what's next, right? Who knows what's next, right? We don't know. You've got to build in scalability from the beginning. You've got to consider it from the beginning. So in terms of formats and workflows, the stuff that's going to drive that scalability in terms of functionality capability, I think there's no end to this stuff, right? Key point is we don't know what it is right now. If we knew what it was right now, we wouldn't have to provision for flexible scalability. We just design it with a timeline, a calendar. So one of the key things I think is to take away that what you need to do is consider your requirements and then consider how IP can give you flexibility. Now, with COTS, flexibility to me, off-the-shelf kit is kind of the key benefit of the move to IP. These guys have been doing this flexible stuff forever, and we can jump on that train and do it with them. So the title of the presentation was about how do we tie this back to cloud principles. Those are the guys that are driving the technology. They're driving the way people are using networks. They're driving the way that NetOps and DevOps are going. That's the train to get on. What they do is they use vanilla standard IP. They don't try and do anything too complicated. They want to buy a switch. They want to buy a switch from multiple vendors. They want that to behave the same. They want to be able to use it wherever they use it. No vendor lock-in. That's what you want, right? You want to be able to move forwards and replace that switch with something else next year or in 5 years' time, knowing you don't have a proprietary infrastructure that means you cannot choose another vendor. Vendor lock-in equals more money, limited choices. So go for standardized IP. Go for things that are real. Go for things that have proper RFCs. BGP. People kind of get a bit confused when I talk about BGP. Isn't that the way the internet works? It is the way the internet works. So do you know what? It has been thoroughly tested at scale. It has been thoroughly tested in an environment where things change. It is massively resilient. It is very fast to converge. It's a very smart routing protocol. You're probably standing there wondering why I'm talking about a dynamic routing protocol in a media environment. If you've got a couple of switches, maybe you can do it statically. You're starting to talk about scale. You want to build this big. You don't want to be provisioning thousands of static routes in your network, worrying about whether you've got the priorities right. You want to leave the smart stuff to do that. The smart stuff in the switch is basically the software stack. That software stack is the thing that adds value to a switching ASIC. BGP, thoroughly tested, works really well, converges very quickly if you get the right stack. You also want an extensible network operating system. That's the software that sits on the switch, right? You want something that you can upgrade, add features to, fix bugs, patch when there's a Linux kernel security issue. You maybe also want something that you can add features to that you didn't think of today. You know, do you need to add a DHCP server somewhere? Well, probably stick it on the switch. Do you want to run some scripting that looks at the status of the switch and actions on that? Yeah, stick it on the switch. I mean, that, for the broadcast guys, I know where you're coming from. That's a bit scary too, right? Actually, it's the way the cloud works. They've got tons and tons and tons of stuff running on their big Linux server, which happens to be attached to a massive forwarding ASIC. They're running this extensibility every day of the week. They're adding functions, enabling workflows, making sure that they can move forwards with other things they didn't think about at the time. The feature wasn't there at the time. If you've got a Linux-based thing, you can just yum a bunch of stuff onto it. It's your switch. You don't have to, but you can. Demand a rich API, multiple rich APIs. One of the things about broadcast is every single vendor out there has a different way of addressing the end requirements, and every customer has a different way they want to work. And so you absolutely have got to have a bunch of different APIs available to achieve the things that you want to do with the switch. Now, it might be a programmatic version of the CLI. It might be open config. It might be a vendor-specific API. It doesn't really matter. The more APIs you have access to, the more opportunity you've got of leveraging smart features and of being able to do the thing that you wanted to do, which hadn't been considered in the first place. Telemetry and monitoring, I think that's pretty obvious, right? Right now you can go and buy a WFM for your SDI, you can plug it in. We're moving to a world which had like 2 or 3 layers in OSI terms. We've got 7 of them now. Stuff you're talking about is up in the top one. You've got 5 other layers you might want to worry about. What you need is telemetry to help that not be a thing you need to worry too much about. You want to know what the routing tables have got, what the snooping tables have got, what the MRAT tables have got. You want to pull that data out and do something with it. I think I'd probably talk about, well, actually, I'll tell you what, I'll talk about that subject tomorrow at, can't remember what time, but that, I like that presentation too. You want more bandwidth. Why do you want more bandwidth? Scaling bandwidth is because you're doing HD today, you'll be doing 3 gig tomorrow, you'll be doing 4K the day after, you'll be doing immersive 365 at some point, 360 maybe. You don't know what those workflows will demand. You know, we're moving to a world of kind of public people broadcasting stuff from their phones. You can imagine tons and tons of content that you may ingest through various mechanisms, which you then need to pump around your system to create the content you deliver. This is a great curve. 40 gigs, 10 gigs, they're tailing off, okay? Look around this room, there's a lot of 40 gigs, a lot of 10 gigs. Not so much 25, 50, and 100. That's the stuff that's being driven by the data center market right now, okay? 10 and 40 gigs are dropping off, no change in price. 25 and 50 and 100, data centers going up, price coming down. So whilst those optics feel expensive, actually if you do a calculation like a buck per gigabit, 100 gigabit stuff is cheaper, okay? You also think about that in terms of density. It's 2.5 times as dense. It goes down the same fiber, so there's no extra fiber cost, but you're suddenly losing 1 over 2.5's worth of RU space. You know, you could have one rack unit thing, you need like a 3 rack unit thing. So make a careful decision about which rates to be going with on your interface ports. Buy a modular switch, you don't have to worry about it. Of course, you can check another line card in. At the edge, you're probably going to buy a fixed format thing. Okay, at some point you might have to replace that, go from 40 to 100 or go from 100 to 400. These are the things I think we need to think about. We need to think about how we move forwards. The scalability can be provided. It doesn't have to be baked in from the day one. You need to be able to, like I've forgotten his name, the chap from the BBC is talking about, You might want to take one network down to do that work and bring it back up again. That's what Dash 7 will get you, right? As I say, fibre is inexpensive. Stick it in. Chuck some more stuff in. It's more expensive than digging up the car park. So, you know, if you know what you're going to use, stick some multiple of that stuff in. The nice thing about the fibre is it doesn't care what you're putting down it. It's just light. You can put 10 gigs today. You can put 25 tomorrow. You can put 400 early Q1. You can get optics that interleave that run at different frequencies. You can interleave tons of those, 80 of those. You can get 9 terabits of stuff down a fibre. So that costs you at the edges, but the fibre is not a limiting factor. You're all very quiet out there. Nobody want to interact? Everyone happy? I can see smirking people.
So in addition to the high-speed video network, you also have a management layer where NICs and devices are still operating at 100 meg and gigabit stuff. Could you talk a little bit about the secondary infrastructure that is in play on?
Yep. Yeah, sure. So that's a good point. And of course, audio, where typically the data rates are lower. So yeah, I mean, the bigger switches tend to kind of bottom out at 10 gigs. I mean, you can run them at 1 gig, but you're wasting 90% of a port. So I think you're very quickly heading towards some sort of a spine and leaf and spine or hub and spoke, where you have access points which are providing different functionality. So management networks tend to be separate. I think that the BBC guy talked an awful lot about security and why he separates those things. I think that's I'm not going to argue about that, right? Those networks tend to scale very well because they tend to be very underutilized. Put some redundant links in, use MLAG, you're probably absolutely fine. To talk a little bit about Moore's Law for silicon. So we all know what it is in terms of x86s. Every 18 months, 2 years, you double the processing. Oh, whoops. What do I do now? Have I turned it off? No. So Moore's Law for silicon is running faster than that. They're using older geometries than the Intel guys, but they're catching up quickly. So they are currently doubling the size of the switching ASICs, roughly 12 to 18 months, rather than 18 to 24 months, right? So what that means is if you use merchant silicon, you can keep hopping on the next bus. So, look at that curve. That is a very strong growth curve. What that means is every 12 to 18 months, you get double the number of ports, double the table size, double the speed of interfaces, okay? So you are looking to buy some infrastructure and you're looking to amortize it over 10 years like you always have done. That may not be the right way of doing it in this environment if you're looking for continuous scale and growth. You may need to kind of accept that some of those edge points are going to get thrown away occasionally, replaced with newer models. What do you get? You just get more density, right? That may be the answer to how I cope with HD today, 4K tomorrow, 8K the day after. So, let's talk about kind of network architectures. This is a very kind of high-level thing, right? If this stuff is interesting, then please just contact me and we can talk in more detail about it. Generically, you can fit one big switch, as big as you need it to be, right? You can build a hub and a spoke. By that I mean a single spine with multiple leaves. Or you can build a leaf and a spine, by which I mean a traditional data center cloud architecture, multiple spines, multiple leaves. They've all got pros and cons. I'll go through those. I think you need to go into this with a clear understanding of your requirements. What is it you are trying to achieve? What do you want to get to next? I've said that like three times now. It's really important. You can't go to a network guy and say, hey, how do I do this? Because the network guy has no idea what you're trying to achieve. And your facility will be different to everybody else's. Your requirements will be different. How many hosts you need? That'll be affected whether you go by 10, 25, or 40, or 100 gigs. Do you need blocking or non-blocking architecture? It's an interesting question, right? I'm going to cover this. You need non-blocking elements. Every single one of these must be non-blocking, otherwise you have no ability to guarantee anything. But do you need non-blocking between every single one of these? Right? Most people in here who run a facility will have a big router in the middle, and they'll have little satellite routers at the edge. They don't have non-blocking infrastructure. They have tie lines. They have a limited resource which they manage. What does that do? Makes it cheaper, makes it more affordable, makes it more flexible. Throw one away, put another one in. So I'm suggesting that is a perfectly reasonable approach in this new IP world. P2P distribution, resilience options, failure domain size. These are, whether that's physical, layer 2, P2P, these are all things that you need to think about. How many levels of failure do you want to accommodate? How much of the system can fail before you're off air? How much can you afford to provide that resilience more than twice or 3 times, for example? These are all things that you need to consider. I cover the one big switch scenario, right? They come pretty big. That's a 16-line card, 36 ports, each of them is 100 gigs. That's over 2,000 physical endpoints. Now, at 25 gig, that's 2,000 times as many streams as you would like to put down 25 gig. What's a good number? Like, let's call it 8, right? No, sorry, 25 gig. UHD, let's call it 2. That's an 8K squared 4K router. Did you need any bigger than that? Don't know. It's really simple. IGMP. It isn't blocking. You can achieve, and we are achieving, the industry is achieving this in many places. NEP Australia, NEP Wimbledon, the Timeline Truck, the Bloomberg building. They're all running simple, big, modular switches. No complexity in the control surface at all. Please take this and join it to that Go. It doesn't have to be a big switch, it doesn't have to be modular, it can be a small one. Depends on your size, right? Benefit of these things is they grow. You don't have to populate it fully. You can just add more stuff as you need more stuff. That's down to you. All you have to do is decide how big you may ultimately want to be. And I've covered the non-blocking thing. We'll come back to that in a minute. See if we can get rid of some of these. Right. Hub and spoke. So by hub and spoke, I mean a single spine, multiple leaf. Obviously, in all of these drawings, there's a second network, okay? A, B, amber, blue, whatever. But for example, I'm going to come back to the non-blocking now, right? Why would I build a hub and spoke architecture? Well, I want these in a geographically diverse location. I want to make these have some connectivity to the function they're performing. I don't know why else, okay? But think about this. If I put the same uplink as host downlink, all I've built is fabric extension. I might as well take that away, just run longer fibers. They're not longer fibers. They already went the same distance. So as soon as you're talking about this sort of architecture, you've talked yourself straight into a blocking tie line IP architecture. Does that make sense for everyone? I think it's a really important point. This architecture does not get you non-blocking without very high cost, in my opinion. This architecture is great as far as I'm concerned, because it matches central core routers with satellite SDI routers with tie lines between them which are managed. Cheaper. How are you going to upgrade this? Well, you're going to put more line cards in here, you're going to add more leaves over here. You're going to change this link to a 400 gig link. How do I do that? Well, I put a new line card in. What about this one? Yeah, you probably have to throw that away and replace it. But, none of this is going to be free and last forever as it is built on day one. You do need flow orchestration. Even if you made this one-to-one provisioned, this would be multiple links. At that point, it's almost certainly going to be ECMP. Could be LACP, but I wouldn't recommend that. That ECMP is not dynamically load balanced. It's a statistical load balancing, which if you want to get close to what that can deliver, you need to orchestrate that. So you need to talk to somebody who has a software-defined networking solution in the control stack, or somebody who's doing timeline management. You need the API in the switch. We're back to that point. You need the facilities, the availability of APIs to perform the direction of flows up specific links. Okay, obviously you can do that. You're going to be doing that up here and be doing that over there. So, yeah, think about your non-blocking requirement. Think about who your control vendors. I'll have to speed up. Leaf and spine. So this is like a traditional leaf and spine. Everyone knows what one of those looks like. Spines, leaves. It's a great architecture for future thinking data centers. It's exactly what the whole of the cloud is built on. It is not a great architecture for multicast. It does not scale for multicast. Okay? I've got a complicated drawing I'll gladly do with anyone that wants. That is not a scalable architecture. Now, what makes sense to me is to have a red side and a blue side, maybe connected together, and then start thinking about your future converged data network, where you have diversity, because these yellow connections aren't used. You can run 2110, use flow orchestration to protect that, and you can then maybe run, if you wanted to, VXLAN or something else over the top, storage services. Once you protect your 2110, you can do anything else with that network. You can start running other services on that network. But do remember, it does not scale. So if you want to expand, how am I going to do this? I get a lot of questions like this. Well, you could start with a leaf pair -7, right? That's perfectly okay. At that point, the PTP will come in here. You could add a spine. If you actually wanted to treat that as two leaves, you could call it a spline. So it's a leaf and a spine, okay? Hang services off that. Later on, you want to expand further, fine. Start adding the leaves in, okay? So all you really need to think about is whether you're starting with a leaf or starting with a spine, and size them accordingly. PTP-wise, if you use boundary clock or transparent clock within the network fabric, it doesn't really matter where you add it, as far as I'm concerned, right? If I add it here, because that's the first leaf I added, you can still boundary clock it to everywhere else in your network. This endpoint has got a little bit of asymmetry. Is it going to be as perfect as this one? No. Does it need to be? No. The 2059 spec is pretty wide, plus or minus 500 nanoseconds. Boundary clocks through your entire system over 3 hops. Absolutely no problems whatsoever. Does that make sense to everyone? So let's talk a little bit about, I'm going to cover this one, right? Data center guys that get really grumpy about this. Network architects that get really grumpy. Why would I add something to my spine? That's not where you're supposed to add it. In my opinion, the only reason not to do that is because these are going to be big ports. They're going to be 100 gig ports, 400 gig ports. So you're just burning expensive ports if you're adding smaller things. But if that's a vision mixer, should have drawn the vision mixer, maybe that's a shared service, in which case maybe adding it to the spine is a brilliant architectural move. It's now available everywhere, right? There's no rules. It's your network. Let's cover PTP. Talked about boundary clock, transparent clock. If you're going to put in a single switch, do you know what? You may not need PTP, boundary clock or transparent clock. Multicast delivery is probably absolutely fine. It's going to depend on how big it is, the number of end devices you're trying to support. As soon as you're into a multi-switch topology, yes, I would definitely recommend boundary clocks and transparent clocks to scale it and distribute it. Think very carefully about which GM you choose. They've all got pros and cons. Some can support a lot of slaves. Some can't support as many slaves. Some have other features that are useful to you guys. Are you building a hybrid system where you want some black and burst as well? In terms of delay requests, the unicast model for me is a better model. Takes the load off the slaves. They're not all having to respond to everybody else's delay request and delay response, or filter them out, sorry. So I would, multicast sync, unicast delay response, request and response if you can. Slaves often have different requirements. We heard that earlier on, right? AS67 is a different profile range to 2059. If you have a flexible boundary clocking system, you can run these ports at whatever rate you want. You can run your AS67 at a lower rate, you can run your 2059 at the higher rate. That's flexibility. It's also going to stop you from knackering your low processing capability audio devices, and it's going to stop you from having to run your 2059 globally at a lower speed. So your GM can run fast, then you deliver what you need locally. Let's not forget the DevOps guys. These are the guys that are going to make your network still work in 2 years' time, 3 years' time, 4 years' time. They're going to spend a lot of time configuring switches, monitoring switches, adding features to switches, writing tools that sit around the switch. What we found in the data center world is there's a lot of guys who are very adept with the server tool sets. There's roughly a 10-to-1 ratio of switches to servers. So there's likely to be a 10-to-1 ratio of server config knowledge to switch knowledge, okay? So make sure that you can support the stuff that those guys can do. These sorts of tools here, Chef, Puppet, Ansible, they're all very, very widely used in the data center, and they're very, very widely used by the server community. You can automate, you can monitor, you can script, you can do all sorts of really cool magic stuff as long as you've got the APIs and the tool sets. OpenConfig, that is a vendor neutral, defined by the community, includes Microsoft, BT, Sky. It's a Yang model-based configuration and telemetry standard that, as I say, is vendor neutral. So if you start using that, you can use it on whichever vendor switches support that, right? That means you can write a bunch of scripts once. So if you want to add an ACL, probably it should be the same model. It should be fine. You can start to not have to write hundreds of different systems to interconnect to your switch. Key things you're going to get out of these tools: automation. You can enable, you can automate processes, automating the quarantining of new cameras, automate the addition of a VLAN, automate the shutting down of a port you're not using anymore. Talked about that one. Comprehensive telemetry. Because we now have these 7 layers rather than 2 layers, you need to know a ton of stuff about the underlying infrastructure. Telemetry is the thing that gets you that. OpenConfig comes with streaming telemetry, which is lovely. Streaming telemetry gives you timely, fine-grained data, not at the 20-second SNMP polling interval, and without dropping any data because the interface went down, it came up, you didn't poll the down. If you want to hear more about this stuff, Monday 4:30 is when I'm back. So I am attempting to end on time, but I see I've still got 7 minutes. So the guys in the cloud, they are all about increasing performance, efficiency, driving down OpEx. That's why they're all about standards, flexibility, openness. That's why they're about these tool sets, because they can drive down the cost of managing by having flexible availability and flexible mechanisms by which they can influence the network. Going to kind of cover the key points again. So, standardized IP, no vendor lock-in, vanilla. Use proper standards. There's lots of vendors who have over the years invented things, and they're perfectly interoperable with themselves. But that's no good to you. That's locked you in. You need to be using real standards. IP is all about real standards. Network operating system, we've talked about that. I think multi-switch architecture is the way to go for growth. It also is probably the cheapest way to get a big system, as long as you can understand your requirements for non-blocking, as long as you can categorize what you absolutely need to do and have a resource management mechanism to achieve that. That won't come from a switch vendor. It'll come from the control guys that you already know and love. It'll come from Axons and Lavos and Imagines and GVs and BFEs and who have I missed, Skylines, and it'll come from those guys, right? Which APIs? Telemetry and monitoring. Kind of ended on a down, but never mind. So, any questions?
Hi. In terms of what you mentioned, A and B or red and blue networks, in your experience, how feasible is it to have vendor, two unique vendors providing for the A and B
Great question.
independently?
Yeah, so
and what are the pitfalls, or
okay.
what are the main challenges around that?
Okay,
Thanks.
so that's exactly what RTL BC in Luxembourg have done. They have an Arista switch and a Juniper switch. So they have this independence. The upside is that they were very early on in the process. So they were unsure that they were a Juniper house. They were unsure about Arista. What they got was two systems which they were very happy with how this one could be configured and not so happy about this other one. In reality, what it's meant is they've got two sets of everything now. They have to have people that configure both. They have to have people that monitor both. They have to learn two tool sets. They have to do X, Y, Z, ... I don't see the benefit, right? If somebody really, if your switch vendor releases a new set of software and it breaks a feature, you're going to test it first, right? You're going to test it, make sure it works. You're not going to put it on both switches at the same time. That would be stupid. You're going to put it on one switch and you're going to verify it works okay. You've probably got a lab where you're going to test it anyway. So, I mean, you're into a weird scenario. You're in a scenario where you have a bug that is going to take you off air and you need a feature that's not available. And so, I don't really, it's been done once, to my knowledge, maybe more. Personally, I wouldn't do it. It works in the data center because they are already all over having to be dual vendor. They don't have a problem with it. It's part of their cost. But we're smaller. I'm not sure it's a benefit.
Hi, Richard Cartwright, Streampipe Media. I actually just was interested that you put Moore's Law up there. I was also trying to talk about Moore's Law in the conference yesterday. I was wondering if we could draw a graph where we had Moore's Law going up on a logarithmic scale, so effectively a straight line, versus the capacity required to move and process media as we go up from 2K to 4K to 8K as we increase the frame rate and as we and the data rates go up due to wide color gamut. I think that would be a really interesting graph to draw. Do you think we could draw that graph?
If you're happy to help me, I'm happy to give it a go. Yes.
Yes, because I think that'd be an interesting.
Okay.
Where is the inflection point? Where did we cross over?
I kind of my gut instinct is that this is going to carry on going.
Yep.
But that the need for, I'm not sure where the need for data carries on going, but then that's the whole point, right? We don't know. So, yeah, I think that'd be interesting.
Yeah.
Happy to help.
Thanks.
So on that same graph, can you put power? How do you, if you're building a data center and you're provisioning rack space and you're provisioning bandwidth capacity, things like that, how much power do we realistically need to accommodate future growth?
That would be a great graph as well, because I suspect it's lower, right?
Okay, I hope so. Yeah, I hope the milliwatts or microwatts per bit are going down.
Yeah. Well, remind me. I'll try and get that right, because if you think about a 1152 squared router, that's 1152 squared lots of 75 ohms, right? That's a lot of 75 ohms. How many 100 gig ports is that? It's not many. It really isn't many. I mean, it's probably a 1RU switch. What's the power of a 1RU switch? It's 200 watts or something. I mean, we should do that maths, because maybe I'm wildly off, but if you take out the fact, it's the same as the cost argument, right? If you take out all these nasty gateways, you get some lovely native IP stuff, I think the size goes down, the power goes down, the cost goes down, the flexibility goes up. We've got to get to that bit as soon as we can, in my opinion.
Okay, any other questions?
I'm just going to make one
Sure.
very quick.
Sorry.
Right, so on that similar subject, right? The timeline truck is 25 gig. They saved 25% of the weight of that truck when they didn't put the copper in, right? 25% of the weight of the truck saved in not having BNC cabling. There's a stack of good stuff in there. Thank you.
Okay.